Hello students. Today we will see the topic network devices. Now when we are connecting the computers or end devices in the network, we require the different devices other than the end devices. We know the list of end devices. Now today we'll see the some devices which are also required when we are connecting the device to the network. These devices are first one is repeater. Now when the distance between the two networks is more, then or the distance between two end devices is very large, then we require the repeater. What the repeater does? Repeater just regenerate the signal. Signal regenerating is the work of the repeater. It is not regenerating the volume or anything, it just regenerates the signal, or it will not add any some new volume or voice or the data in the original one. It just regenerates. So it has only two ports. So it is also called as a two-port devices. Now this repeater works at the physical layer of the OSI model, whatever we saw in OSI model. So it works at the physical layer. So it is also known as the first layer device. So repeater which just regenerates the signals when the distance is large, that time signals gets weak. So after some long distance, to get the original sound or to get the original signal, it is sometimes difficult because that signals becomes weak. For that purpose, we require the repeater. It has only two ports and it regenerates the signal. Next one is the hub. Now we saw the star topology. In star topology, when we are connecting the many different devices in a LAN, we require hub. So this is a diagram of hub. Now here you can see there are so many different ports are there. Now these ports, what they are doing, they are accepting the data and passing that data to other all the devices which are connected here. So it gives us a connection to many different devices to create a star-like topology. Now, when we are thinking about this, this device also works as the physical layer. So this is also a layer 1 device hub. Now, another is it broadcasts the message. What is mean by broadcast? Whenever, for consider in a star topology or in a one LAN, there are 10 PCs are connected with each other. Then one PC is sending some data, it goes to the hub and hub transfer that data to all the remaining connected PCs. Again, when any PC for whom that data is there, that sends the acknowledgement. So that acknowledgement also transfers to all the other connected devices. That other devices has to delete that packet because it is not for them. So it transfers that and it is called as the broadcasting. So it broadcasts the data on the all the devices which are connected. So that's the hub. Another one next is the switch. The switch is intelligent than hub. So in a LAN, to connect the devices, we can use the switch also. Switch is, we can say switch is an intelligent hub. Why? Because switch is having a memory. Now the working of the hub is to broadcast, whereas the switch properly sends the packet to the particular device only. Whenever, suppose 5 PCs are connected and one PC is sending data, then switch finds out or check the MAC address and it transfer to that particular one device only. It will not broadcast to all. If required, it broadcast also. Otherwise, it maintains a table, and that is called as the MAC address table. MAC table, MAC address table means the information of all the connected devices with port number and MAC address. So it contains port number, on which port which device is connected, and what is the MAC address of that device. So we called it as an intelligent hub. Now this hub works at a layer 1, whereas this switch works as a layer 2, means at data link layer, because the MAC address is given by data link layer. So we call switch also as a layer 2 device. We will see hub and switch today in detail by using a Cisco packet tracer also. Next is router. Now router, this is a router. Router is used to connect different LANs. When the LANs are different or two different networks, small networks are there, to connect that different LAN, we are using the router. What router is doing? Router is sending from one network to another network. Hub and switch in a single network we are using in one LAN, whereas router is used to connect different LANs. Now router as well as bridge, both are the use of both the devices is to connect different LANs. Then what's the difference between bridge and LAN? So दो LAN को या दो से ज़्यादा LAN को connect करना है, then we are using router or bridge. As there is a hub in one LAN, same way bridge is there. Bridge is also passes the message to all the devices which are there or to the particular switch in a LAN. So one LAN to another LAN, bridge is there. Now bridge is used when the protocols of that two different LANs are same. So here main is protocols are same. LANs are different, but they are using the same protocol. So that's bridge. Whereas router is also used to connect the different LANs, even if their protocols are different. So LAN, WAN, to connect that, we are using the router, or it is an intelligent bridge also we can say, just as a switch. So router is used to connect the different LANs with different protocols. That's the main thing with different protocols. Router maintains a routing table. So routing table means where to pass the information or which path has to select when packets has to pass. So that routing table it maintains and updates frequently that routing table. So it is again we call it is an intelligent bridge. It works at network layer means layer 3. So this router works as a layer 3 device, whereas bridge is a layer 1 device. Next one is router. Router is same as the or the combination, or we can say it works the bridge and repeater works, and that is the router. Next is NIC. So this is a diagrammatic form of the NIC, network interface card. This network interface card is inbuilt in all the PC, and with that only we can connect the end device to the network. And on this network INIC card, there is a MAC address which is given by the manufacturer. So NIC network interface card is an inbuilt which is required to connect the device to the network. Next is modem. This is modem. Modulator. There are two different terms in modem, modulator and demodulator. Now, as we know, computer passes the signal which is in digital format, 0 and 1 format. But to transfer that signal on a transmission medium, it has to convert into the analog signal. So the work of this modem is to convert digital signal to analog, and again at the receiver side from digital to analog. So that is the modem. Previously, we have to attach the modem separately. Now it is inbuilt in all the devices. The last network device is firewall. Firewall is used to secure the network. We can give the more security by using firewall to our network. Now, firewall restricts some sites, or we can restrict some sites by using the firewall, and we can protect our network by the malfunctioning. So, all these are the network devices we have to use when we are connecting to the different devices. Now, we will see hub and switch, how they work, and then we will see the difference between hub and switch. So we will come to the Cisco Packet Tracer. Now this is the window of Cisco Packet Tracer. First we will see the working of hub. Now here we will connect 3 to 4 end devices. So PC1, PC2, PC3. I'm taking 5 end devices, PC4 and PC5. First, we will connect this by using the hub. So network devices, select the hub. So I'm going to the hub part, and I'm taking this hub, and I'm connecting this with this hub. Go to the connection, select this one, and connect this PC to the hub. So it is fast Ethernet. Connect this. Now here we can see there are total 6 ports in this hub. So we can see 6 ports are there. So maximum 6 devices you can connect with the hub. If we want to increase the capacity of hub, then we have to connect more hubs to the network. So this is like this. I'm connecting all these 5 devices to this hub. This third, then next fourth, you can connect maximum 5 devices. Sorry, 6 devices here. So I'm connecting here 5 devices. If you want to see the hub, you can click it here, and here you can see in the physical tab, you can see there are 6 ports in the hub. So 6 different devices we can connect. Now we will give here the IP address to each device. So go to the first PC, desktop, click go to the configuration and give here the IP address. So I'm giving here 10.0.0.1 as the first IP address. Click on the subnet mask and close this one. Go to the second PC, desktop, configuration, give the IP address 10.0.0.2. Click on subnet mask, close this one. Third one, desktop, configuration. Here give the IP address 10.0.0.3. Subnet mask, close it. Go to the fourth one, desktop, configuration. Then 10.0.0.4. Subnet mask, close it. And then last one, fifth one. So desktop, configuration 10.0.0.5. Subnet mask and close it. So we connected these things by using a hub. Now we will go to the simulation mode so that we can see how it works. So click on this simulation part, close this one. Now window, and now I'm selecting the PDU, simple PDU, which I want to pass from one PC. Now I want to pass this PDU, for example, PC0 to PC4. Now you can see here. Now this passes to hub first. Now hub sends that device to all the PCs. You can see all the PCs. Now this packet is only for this device. So the other devices has to reject it. Again, click here, forward, and now it sends the acknowledgement. That acknowledgement also passes to all the other devices. Now, as this is the sender, other devices again has to reject it. And that is called as the broadcasting. So hub broadcasts the message. It passes the message as well as acknowledgement to all the devices. So the problem occurs in this type is the flooding. So maximum time all these devices are all these paths are full because it has to transfer the information to all the devices. This is hub. Now we will take a file new, and now we will see the switch. So I'm taking now the end devices. So PC1, instead of now hub, we will take the switch 1, 2, 3, 4, and 5. So these 5 devices, we will connect it by using a switch. So now this is the switch. I'm connecting this one by using a switch 2960, for example, first one, and put it here. See the switch. Now here in this particular switch, there are 24 ports. It means 24 connections are there and you can connect 24 devices. Close this one, connect this one, all the devices. Now here we took just 5. Otherwise 24 different devices you can connect with this switch. Select any fast Ethernet from this and connect all the devices with the fast Ethernet cable. So I'm connecting with anyone like this, connect it, then fourth and fifth. Now you can see one side their arrow turns into green, but other side it has to require a time. Now we will give the IP address to this one. So go to the desktop, config, and give the IP address as 10.0.0.1 subnet mask. Close it. Go to second PC, go to desktop, configuration, second IP address 10.0.0.2. Click the subnet mask, close it. Then third one, desktop, configuration 10.0.0.3. Subnet mask, click on that, close it. Now fourth, go to desktop, configuration, and type here 10.0.0.4. Click on subnet mask, close it. And the last one, fifth one, desktop. I'm just showing you the example. So you can reduce the number of PC as well as or increase the number of PCs. So we gave the IP address to each one. Now we will see how this switch transfers the packets. So we started with the simulation mode. Now take this one packet, put it here. Now I want to pass this to particular this PC3. So click it here and see the transfer of the packets. Now what switch does actually? Switch passes the packet. First time it shows like this, but afterwards it shows that only one, it passes to only one because the switch requires a time to. Now you can see here first time. So again, now next time again, it has required the time to create a table, MAC table. Now you can see here second time, from second time it transfers to only that particular PC. Again, acknowledgement is passed to that particular PC only, whoever sends it. Okay, now here there is no broadcasting, it is a unicasting. So switch works as a unicasting, multicasting, or broadcasting also, depending on our need. So that's the simulation of both. And now we will see the difference between hub and switch. So hub is a physical layer of OSI device, means the layer 1 device. whereas switch works as the data on the data link layer. So it is also called as a layer 1 device. This is layer 0, or if we are saying physical layer as a 1, then it is a data link layer as a layer 2. Hub is broadcast type transmission. Hub transfers the message to all, whereas switch is a unicast, multicast, or broadcast type transmission. So depending on need, we can do that one. Hub have 4 to 12 ports, whereas switch is having 24 to 48 ports. So the capacity of ports also is more in switch. In hub, there is only one collision domain. In switch, different ports have own collision domain. Half duplex transmission mode. So hub works in half duplex transmission mode, whereas switch is a full duplex transmission mode. In hub, packet filtering is not provided, while in switch, packet filtering is provided. Hub cannot be used as a repeater, while switch can be used as a repeater also. Hub is not intelligent as there is no memory present in hub, whereas switch is an intelligent and memory is there in the switch. Hub is simply old type of device and is not generally used now naturally. Why? Because we have the intelligent hub. So we are using switch is now very sophisticated device now widely used in the LAN. Hacking of system attached to hub is complex, whereas hacking of systems attached to switch is little easy. Speed of original hub is 10 Mbps to 100 Mbps, whereas maximum speed of switch is also 10 Mbps to 100 Mbps. Hub are used in LAN, switch is also used in LAN. Cheaper as compared to switch, whereas it is very expensive as compared to hub. So by using Cisco Packet Tracer, we saw the differences, and I think it is now clear to all that how hub and switch are working and where we can use this hub and switch. So here we will stop. In the next lecture, we will see the working of the router. Thank you very much.